a couple of really excellent presentations. I know they'll be excellent today from Justin Reese and Arti Patel, extracting knowledge from the N3C Enclave and N3C tools and tips. And so we continue making progress in our effort. We have 57 sites with data released, 219 sites with the DOE executed, and 88 sites have executed data transfer agreements. And let's see. Okay, so Justin, I think you're next, and I think I hopefully you'll be sharing your screen because
Yep.
I don't have your slides, so I'm going to stop sharing.
Okay, can everybody see my screen?
Yeah, if you can put it in presenter mode, that would be great.
Okay.
Perfect. Thank you.
Okay, awesome. Okay, so hi everybody. I'm Justin Reese. I'm a computational biologist here at Berkeley Lab. So what I'll be talking about generally, I'll term extracting knowledge from the N3C Enclave. So this will be sort of a survey of the 5 or so, maybe more now, if you, depending on how you count, of all the projects our working group has been working on. The effect of COX inhibitors on COVID-19 outcome. I've been working on this in coordination with Hannah Blau and Peter Robinson, and Metformin versus COVID outcome. This has been being led by Lauren Chan, who's a great graduate student in Melissa Handel's lab. Psychiatric sequelae of COVID, led up by Ben. Knowledge graph for long COVID symptoms, headed up by Tia Morali and Blessy, and leveraging Tiffany Callahan's work. And then BMI imputation, which is sort of something we've been working on with Elena Kasaragi. So yeah, like the sort of the umbrella thing I'm going to be talking about is extracting actionable knowledge from the enclave and sort of the lessons we've learned and technical and other kinds of challenges. So here is KG COVID-19. So let me rearrange my screen. Can't see the whole slide now. This is a project we started about a year ago to integrate all of the publicly available COVID-19 data. You can see it on the left. It's sort of a schematic diagram of all the data that we harmonize. This is ontologies, publicly available COVID-19 data, proteins, genes, publications, drugs, phenotypes, gene function, PPI, and this is all available. This is, by the way, available in the N3C Enclave. There's a paper there that describes all of this. But broadly speaking, this is about 500,000 or so biological entities and 24 million relationships between them. And so we use this to identify drugs that might be involved in COVID-19 in the following way. So on the left, we have sort of a schematic diagram of KG COVID-19. We apply a graph machine learning algorithm called node Devec to embed each node into latent space. And so the place it's put in latent space encodes all the information we have about it. And so if you think about it, SARS-CoV-2 is in there, all the 30,000 or so drugs we have are also in there. And so this gives us a way of ranking drugs by how involved they are with SARS-CoV-2 and COVID-19. On the top right is just some metrics to show you that if you do link prediction on these, that the AU-ROC is actually performs quite well. But obviously we want some sort of way to tether this to real EHR data. We can't just go out and give these drugs to them, assuming that the graph ML is working perfectly. So our strategy for that is an observational retrospective case cohort study. So we start with COVID-19 patients. For each drug, we do the following. We'll take the patients who have an indication for the drug. So for example, this was a migraine drug. These would be patients with migraine. We separate them into treated with the drug or not treated with the drug. We align these with epidemiological method called propensity matching, and then we compare the COVID-19 outcome. And then, so obviously, if the drug has any effect on COVID-19 outcome, you'll see a difference when you do an ordinal logistic regression. Here are if you run that pipeline I just described for all of the top 100 drugs, you can see 18 of the top 100 drugs have a significant p-value. So when we looked at this, we noticed that several of the drugs in the top 100 were COX inhibitors. These are NSAIDs and things like that, things that are typically taken without any compunction when you have a COVID-19, when you have COVID-19 or any sort of cold or flu, or aspirin, ibuprofen, and acetaminophen. And so that kind of piqued our interest. So we did a deep dive on the COX inhibitors. And what we found was that COX inhibitors are associated with greater COVID-19 severity. So aspirin and 4 other COX inhibitors are associated with more severe COVID-19, but this is kind of interesting. We also tested COX-2 selective inhibitors, meloxicam, diclofenac, and celecoxib. Those were not associated with worse outcome. They didn't seem to affect the outcome very much. I'm showing the odds ratio here, and they're within 1 if you look at the confidence intervals. So this is actually, I think it's fair to say, met a little bit of resistance when from the community, but it is consistent with previous studies that show that COX inhibitors are associated with worse outcome in community-acquired pneumonia. For example, this paper I've quoted right here. So we presented this several months ago, and Karen Bramante got in touch. She's leading analysis of metformin. Metformin, of course, is a well-characterized diabetes drug, but it seems to also have a positive effect on COVID-19 outcome in diabetics. And so she asked us if we'd be interested in doing a secondary analysis looking at the effect of metformin in non-diabetics. So metformin is used off-label for polycystic ovarian syndrome and for prediabetes. So the question is, does metformin have the same effect in these diseases as it does in diabetes? So we use the same observational studies with the COX inhibitors. So if we consider pre-diabetic patients, we start with COVID-19 positive patients, we remove diabetics explicitly, and then we keep those with a diagnosis of pre-diabetes or an A1C between 5.7 and 6.4, which is symptomatic of pre-diabetes. Then we do the same thing we did before. We assess treated with metformin or not, compared with not treated with metformin after propensity matching for these covariates and several others. And then we measure COVID-19 severity or difference therein using ordinal logistic regression. So our observation was metformin is associated with better COVID-19 outcome in pre-diabetics. So here's the odds ratio and the confidence intervals. Here's the same thing with PCOS. So we remove diabetes patients. We keep only those with a PCOS diagnosis. And then we're making note of who is pre-diabetic and using that as a covariate. And then if you do the exact same experiment as before, we see that metformin actually doesn't have the same effect in PCOS. And so that's an interesting discordance. It's still, we think, interesting information to have. So this is a sort of related project led by Ben Coleman, who's a graduate student in Peter Robinson's lab, investigating the psychiatric sequelae from Longcoded. So psychiatric sequelae, I think probably everybody in this call knows, are very common after recovery from COVID-19. So we can do an observational study similar to the previous one, where the treatment in quotation marks is COVID-19, and the control is another condition, respiratory tract infections other than COVID-19. And then for each of those, we record the follow-up time. In other words, how long do we know, how long of a record do we have after COVID-19, and did we observe any psychiatric sequelae? So what we observed was what other people have observed, which psychiatric sequelae are very common after COVID-19 recovery, and actually much more common than in other respiratory tract infections. And another thing we think is sort of novel that we discovered is that we had a long follow-up time, so we can prove that statistically there's a change point when the risk of sequelae returns to normal, and that change point is less than 300 days. So if you haven't seen a psychiatric sequelae before 300 days, you're probably not going to. We can also ask, are long COVID phenotypes associated with or predictive of psychiatric sequelae? This is also Ben's work. We're also leveraging Tiffany Callahan's work. She's mapped OMOP phenotype data to HPO phenotype data for 70, I think 72 important long COVID symptoms. So we can ask, are long COVID phenotypes associated with psychiatric sequelae? So we start with COVID-19, we identify patients with long COVID phenotypes, and then just assess their psychiatric sequelae. So what we see is that for anxiety disorders, the predictive long COVID phenotypes, so what we've done here is sort of group the long COVID phenotypes into I think 6 or so categories: neurological, general, cardiovascular, respiratory, immunological. All of those are predictive of psychiatric sequelae. Neurological in general are predictive of mood disorders, and neurological symptoms are predictive of dementia. So this is useful in other information, we think, in and of itself, but it also hints at some interesting biology that we could possibly dive into. This is sort of an unrelated, less related project to do with long COVID. So Peter Robinson previously led an analysis of literature to produce a deep phenotype of long COVID. This a lot of people on this call, I think, are on this paper. This has been submitted for peer review, but it's on medRxiv here. But we also actually have a pretty rich long COVID data in the N3C Enclave too. So we can dig those up and ask how they compare to the literature, the ones that Peter has curated in coordination with everybody in the N3C. And then we can also use a data-driven graph ML method to actually cluster the patients in a sort of a principal, a data-driven way. So the first step here is to construct a knowledge graph linking KG COVID-19, which I described at the beginning, to patient-level data, which of course is not in OBO ontologies. This is OMOP. So HPO is in KG COVID-19. So we can link those by virtue of Tiffany's hard work to map all those phenotypes to OMOP. So for every patient, well, okay, let me define some terms here. So we extract phenotypes 3 weeks after COVID-19 presentation for outpatients, or discharge, or 3 weeks after discharge for inpatient. And so in this way, we can sort of link patient level data on the right with publicly available KG COVID-19 data using this knowledge graph. So here's a little sneak peek of the data. The 5 most common phenotypes, if we look into this knowledge graph we just made, are pain, paresthesia, anxiety, arthralgia, and sleep disturbances. And you can see the percentages here. This on the right sort of comports with what others have observed. Most people have between 1 and 10 symptoms. Some poor unlucky souls here have 20 or more, but that's kind of the exception rather than the rule. So an ongoing project is that we have started a few weeks ago is to apply GraphML in a clustering algorithm, which I won't go into here, to cluster long COVID patients by their phenotype. So we start with that knowledge graph we saw before, and out the other end comes data-driven clusters. And this, we think, might be in the fullness of time useful for patient stratification and possibly even precision medicine, depending on what these clusters look like and if they comport with any interesting biology. I wanted to also mention a project we've been doing with Elena Casaraghi, our great colleague from Italy. So others have surely noticed that some data have a very high rate of missingness in the N3C Enclave. So BMI can be as high as 40%, depending on what patients you're looking at. And this is a pretty important covariate for us and probably others. Height, weight, and age also have significant missingness. So specifically, we thought we could make a contribution to the community by imputing data, missing data in the patient severity and scores table, which Richard and Emily and others, well, I guess the whole N3C community has produced. So we've done just that with using 3 different packages: mice, Miss Forest, and Miss Ranger, using random forest and predictive mean matching. This is not quite ready for prime time yet, but we have 5 imputed data sets, and we'll have metrics and related analyses, NCAR, variance between imputations and so forth. And so we'd like to invite other people to use this if they're interested in it. And I know probably a lot of people on the call are actually working on this themselves, so we'd be interested in collaborating with you and getting feedback. I'll just summarize what I've just said. So we did some observational studies of the repurposing candidates, COX inhibitors. I summarized that before. Non-selective COX inhibitors seem to be associated with worse outcome, but not COX-2 selective inhibitors. Metformin seems to be associated with better outcome in prediabetes, but not in PCOS. And we're kind of in the midst of doing a lot of control analyses, and this manuscript is in preparation. Lauren Chan is the excellent graduate student who's been leading up this effort. Psychiatric sequelae, I just summarized before. They're very common after COVID-19, but and this I think is novel. They seem to subside before 300 days, and long COVID symptoms are also predictive of those psychiatric sequelae. I told you about the knowledge graph that we're making for long COVID. This is headed up by T.M. Morale and Blessy Anthony, and leveraging a lot of Tiffany's great work. And as I said, the missingness imputation, if anybody's working on that, we'd be interested in collaborating, or if anybody wants to use the data with this missingness imputed, we'd be more than happy to share that with you. Thanks to everybody in the N3C community, first and foremost. It's been great to working with you guys and girls. And I won't read through all these names, but these are all the people that were instrumental in getting this work done. So thanks for listening.
Great. Well, that's thank you. It's a great talk. Any questions? So I've got a few questions. So the medication studies, the methodology seems very interesting and obviously very generalizable. Yeah, so if you could go back to that, and in particular, using Node to Vec, obviously you could embed a lot of different things. So maybe if you could talk to us a little bit more about what information pertaining to the drug are you embedding? Are you including any kind of structural chemical information, or is this just essentially drug classification or empirical information about what the drugs are known to do?
Right. We haven't explicitly put any structural information in there. We do have sort of things that correlate well with them, but it would be more leveraging. So the first thing to say is Node to Vec will leverage any information you put in the knowledge graph. So any of the things
that's why I'm wondering what you're putting in the mix.
Yep. So all the literature on COVID-19 is in there by virtue of SciBite Cord 19 annotations. These are PPIs, this and this. So any known protein-protein interaction will be in there. Obviously, human genes and SARS-CoV-2 genes, and about 30,000 or so drugs that we know anything about. And then obviously the ovo-ontologies too.
So, because I know that there have been some groups who've actually been doing structural predictions for COVID. I've heard some talks along those lines. Is that something that you've been thinking of doing, or do you think that would be worthwhile? I'm not, this isn't my area, so I don't really have a horse in the game.
Yeah, it's not my wheelhouse either, but Ben Brown, who's an excellent colleague here at Berkeley Lab, has been doing just that using graph convolutional policy networks and has had some success. And we actually collaborated with him using our embeddings to sort of, so his observation was, yeah, you can do GCPNs to sort of design COVID-19 drugs, but what happens is the loss function just every once in a while gets super excited about some drug that is just not drug-like. It just can't be made, or it just looks nothing like any other drug, so it's not practical. And so what we've done is combined his embedding, or our embeddings, to sort of confine the loss function to something that looks more like a drug. And that does seem to, at least to hear him tell it, that does actually improve his results. So that's kind of interesting.
Right. So you've talked about a bunch of really interesting efforts. Are you in a position where you're looking for new collaborators, and if so, what attributes of problems would particularly interest you?
Anybody that wants to work on the projects I've just said, like none of these are really finished in quotation marks. So we definitely, we're a very collaborative and gregarious group. So if anybody wants to work with us on those, we're very welcoming. We would be interested also, I mean, so I mentioned before, so we have like 18 of the top 100 drugs look interesting, and those shake out in a way that you would expect. You know, they're well, the ones that I said, COX inhibitors, there are steroid hormones, there are antivirals, antibiotics also come up. So if anybody wants to do a deep dive on those, especially domain experts and clinicians who know a lot about those things, we're all ears. Also, all the long COVID things that we talked about, I think we would probably benefit from anybody who has boutique knowledge about long COVID, especially I think there's a long COVID group that we maybe should reach out to.
Right. So you had some interesting comments about the psychiatric sequelae, and so I meant to ask, and maybe I missed it, you might have said something along these lines. So obviously from N3C EHR data, you're not going to necessarily know that much about what happens in anybody's head, because of course they're discrete data elements that are, you know, coded in labs and things like that. So so where are you, is this N3C or is this some other data set?
No, it's N3C. The missingness that you refer to is definitely a concern. Like, you know, there's no guarantee that if somebody has depression, they will be coded as so in the N3C Enclave, but there are definitely condition data in there for psychiatric conditions. You kind of have to do, it takes a bit of doing, which is by virtue of all of Ben Coleman's hard work to actually extract it. But I think we'd be willing to show you how to do that if you're interested.
Interesting. So then you're basically looking at longitudinal data, and so there's going to be some frequency of codes saying, you know, anxiety, depression, or whatever, and then those things increase soon after the COVID-19 diagnosis, and then they tail off after time, fundamentally.
Yep.
Okay, that's interesting. Okay, are there other questions? I don't see anything in the chat. Am I missing something? If anybody else sees something, okay. Well, great. Those are really very, very, very cool stuff. Very interesting work. Thanks.
Thanks.
So, okay. So next up is Arti Patel, and I think you're sharing your screen as well. It's going to talk about N3 tools and tips.
Yeah, thank you. So just to introduce myself, my name is Arti. I'm a data scientist at UVA, and I've been working in N3C since the fall, so almost a year now. And I'm a part of the neurodomain team and a couple of other independent DORs, but I've also been a part of the logic liaison team. And so today I'm going to share something we've developed from meeting with other logic liaisons over the past couple of months. So I'll just share my screen. So a lot of people might already know how to get to the knowledge store and how to do some of the basic things that I might talk about today, but I'm just going to start from the beginning. So we've developed a template that helps people build a person level table for analysis, and it's in the knowledge store. So once you're on the home page in N3C, you can click on the knowledge store here. And I'll explain in a minute exactly what the template does. And then once you're here, you can search for the multi-node template for person level table. So once you're there, you'll see this screen, and this will have a few objects attached to it. So we have the templates itself for each of the levels of data. We have the README, which is a report that we tried to keep heavily detailed that you can use as you're using the template. And then we also have example workbooks attached so that you can reference what the template is intended to look like once you finish using it. So this is what that looks like. And then I have the README open in another tab, so I'll go here. Okay, so what does this template do? So we designed this template to help people build this person level table that you can use for analysis. And as we were talking about what we wanted to include in here, we decided to include things that might be common throughout the community that would be of use. So of course, we've included variables related to COVID-19 facts for each patient. We've included any reported death data, certain ventilation procedures patients may have gone under, different types of admission visits, their BMI, and then we also included the comorbidities that were used in the cohort paper. So we recycled those concept sets that were used in that publication. So what do we also discussed, like what did we require that someone who's in N3C and wants to develop an analysis, like what should they think about before using this template? So the most important questions you should ask are, what is the area of research? So usually in a DUR, you have minimum at least one research question in mind, so there could be more than one. And then also what type of, who is the master patient group? Who are the patients of interest that you're looking to study? So here we're using cohort group and master patient group a little interchangeably here. But that's essentially who is the study revolving around? And then third, what we also need is what other variables and patient facts are relevant to the analysis. So some people might think of that as what are any independent or dependent variables? If there's a matching, then what are the criteria that you're going to use for your matching? And then throughout the report, you'll see different examples of what we've included in our example workbook. So there's a snapshot of what the complete workbook looks like when you've imported the template. And I'll be going back and forth between the README and this code workbook that Sean and Saad helped a lot in helping to develop this. So this is in the N3C training area, and they created another version of the template that's compatible with the Cynthia data. So that's what you're seeing here. And so I'm just gonna be flipping back and forth between these two screens as I walk you guys through how to use this. So over the past couple of months, the logic liaisons have met every couple of weeks to talk about what are the tips and best practices that everyone has encountered and learned over this time. And so we tried to compile all of these discussions into things that people should know when they're working with this data. And some of it is relevant to different tools in N3C, some of it is relevant to the nuances of the data. And I know I have limited time here and I want to leave some time for questions, so I won't walk through everything, but yeah, so I would highly recommend going through and giving us a read through when you're importing this template. And yeah, so a couple of the most important things I will say is the date shifting in L2 data that you should be aware of. And then some of the nuances in the L3 data as well, where you can use the manifest table to see if there's date shifting in some of those data partner IDs. And then these data limitations are also extremely important. So one of the ones that I find myself going back to and repeating a lot is that the absence of a fact is not a negative. And a good example of that is that there could be a lag in some of the data with some of the sites. So someone in the logic liaison team pointed out that when there's a lag, you wouldn't see a certain report of a certain event. And so, for example, if the death data is lagging by 1 to 3 months, then you shouldn't assume that that doesn't mean that the patient did not have a death. So yeah, anyway, so I would highly recommend going through all of these data limitations and general tips that we compiled. And then from here on, the rest of this report walks through the individual steps of how to use this template. So the first step is when you import this template, there's 2 ways to do it. You can go from the knowledge store here, and these are the actual template objects. So whatever your DOR is, whether it's LDS or de-identified, you could use one of these. And once you open this, there's a tab that says actions, and then it gives you an option to import it into a workbook. Another option is if you have a workbook open, like a new blank one already open, then you can follow these steps and you'll be able to search for the multi-node template from there when you click on a new transform. The other component that we tried really hard to make in this template is that we want it to be dynamic and editable by anyone who's using it, because we understand that everyone's analysis will differ and that like everyone's study design will be different as well. So another feature of the templates is that you can look at both the code and you can look at the interface that a regular template would show you. So for example, if I click on one of these nodes here, you can see how there's parameters that are set up that allows someone to put in a certain value. This probably wasn't the best example because I have other ones where you can see where it's not grayed out. So here I have a screen where you can enter in your own code set ID for certain concept sets, and then you can change the input tables that you need. And then if you wanted to see the actual logic, you can also toggle view and look at the logic that was used to create this table. And then if you wanted to edit it, you could also do actions and then convert to code transform. And I'll just note that once you do that, it converts permanently to a code transform and it won't be a template anymore. So here I'll just take a few minutes to say how when I first started in N3C, it was a little bit of a challenge because I wasn't used to the interface. And over time, we've developed this because we found that this general structure really helped us improve not just organizationally, but also computationally too. So we've organized it in a way where, and I tried to use colors here. We've tried to organize it in a way where the workflow goes from left to right. And so we start with the red tables, which are the N3C input tables. This is where you'll see the condition, measurement, and so forth. And then we've created another level that says find patients of interest. So earlier when I was saying that once you have an idea of who your master patient group will be, these are the nodes that you will use to write the logic to select those patients. And again, here you can edit those based off of concept sets, you can edit the code. Right now, the default here, these code set IDs that you see here, what it's going to do is it's going to find the COVID positive patients and patients with one other condition. And so again, this can be changed if you're interested in a different condition, but the default in this one shows condition 2 code set ID. You see this 358 number. This is a code set ID for a stroke concept set. You can change this if you wanted to use, let's say it's something for asthma or something, a different type of condition. And the same goes for the other nodes here. So like I have other parameters where you can fill in the code set ID that's used to identify the COVID tests. And then we have another one to identify the positive results of those COVID tests. And so some people might think, okay, well, I know what my master patient group is, but I want to also be able to develop a cohort that was also admitted and we have the reported inpatient admission. So the way you'll construct that is you'll incorporate the visit table into this level, and then you'll connect that to the master patient group. So, I mean, our hope here was that we could provide this skeleton structure so that people can have a leg up in developing this table. But ultimately, anybody who uses this is going to have to tweak it or change it somehow to make it specifically fit your definition and your study design. So after you've added that, there's the master patient group, which is the table itself of the cohort that you're interested in. And the logic we've included here, what it will do is it will just add a couple of examples of certain derived variables that you can make from what you have so far. So like I've added a couple examples of where you can find date differences between certain certain index events. Yeah, so, and earlier when I was saying that this also helps with optimization, because the reason why we've selected this master patient group first and tried to establish this early on is because once you've identified all of these patients, it's easier to query through this smaller subset of all of the patients than it is to query through what might be like the hundreds of millions of rows that is like the condition table or the measurement table. So again, the workflow is left to right. So once you've established this group, then it's much easier to just query for the other variables that you need in your analysis from this already defined master patient group. So then that leads us to the next level, which is the find patient facts. And this is where you'll bring in, let's say, like the dependent variables, independent variables, any matching criteria. I might be missing other types of variables, but we can also just think of it as other attributes or facts that are relevant to your analysis. So I'll show an example here, which is, this is the one for conditions. So if you notice that it's also organized in a way where it follows all of the OMOP tables, so that this one line has the condition table, then the definition for conditions, and then all the way to like other variables that you might add that are coming from the condition table. And so here we've included these comorbidities that were included in the cohort paper. And again, you can edit these out. Like, let's say if these concept sets were updated to have a different definition, then you can change this to a different value. And the logic will show you that this requires patients to have had this diagnosis before their initial COVID diagnosis so that it can be counted as an actual comorbidity at the time of their COVID diagnosis. So I'll go back to the structure. So then that brings us to the master fact table. And this is where we bring together all of the attributes and facts that you brought together in the previous steps. And we'll also add any derived variables that you can make from the columns that you have so far. So, and then I throughout this workbook, we've also tried to optimize the performance by, dropping columns that you might not need so that it doesn't weigh down the memory. So then we have the person level table after that, which is where we aggregate everything. And there might be something in the chat. So if there are any questions, then I see someone said, what is the difference between a code set ID versus concept set ID? So that's a good question. A code set ID is a collection of concept IDs. It can be confusing with all of the alliteration, but they're very distinct because you can use a set of concept IDs and just, let's say, query or filter a data set for, like, let's say 3 different values of concept IDs, or you can make a concept set and then use the code set ID and bring that into the workbook. So we've done that in certain areas. I think I can probably find an example. So here, I'll open the visits node where these individual values are concept IDs and they're being queried in the same field, which I think is visit type. Let me just see. Yeah, so yeah, it's visit concept ID. And then in the other examples I shared, this would be the code set ID, which is again, the collection of the different concept IDs. So, okay, so I'll go back to the structure. And so this is one of the last steps where you're going to aggregate everything into a person level table. So we've added all of the indicators and important dates that we might need, certain ventilation procedures, other facts that might be relevant. And again, we tried to make this as accessible and useful as possible to the community, but if anyone has suggestions, we're happy to incorporate them because the more we have, the more it can help everyone here. So this is also the stage where we incorporate all of these other facts that we've queried for, but also the demographics that come from the person table. So it includes the gender, age, race, ethnicity, and I believe a couple of other things. And then lastly, we just included an example of creating a histogram so that you can have some code to develop some visualizations as well. So, and then one thing I forgot to mention is that this template also includes a feature where it allows you to randomly sample the person's table so that you can test out your code and not have to wait several hours for something to run. And then once you are ready to run on the full data set, you can change it to the full person table. So I'll just show you here. So here in this node, you can see that it's currently using 0.1%. Maybe I should call this fraction because it's not in percentage form, but this right now it's using 0.1%. If you wanted to run on the full data set, then you would just enter 1 here. And then there's also a random seed so that as you keep running it, you should get consistent results. So this idea came from Sean, so thank you. And then the rest of this README, it just contains a lot more detail of like how to get all of the individual variables and how to get from each of the steps to the next one. And then we've also included various logic liaison tips throughout as well, so that you can keep those in mind as you're working. Yeah, so I think I tried to go a little quickly so that we can talk about questions. So I think I'm going to read the chat and see if can a version of this be created that filters out organizations that shift states from all data elements? Meaning if a patient has any data in L3 from a data provider that shifts data, those patients should be filtered out. Yeah, so we do have some logic for that. And I'll just see. So we included a manifest table here. So this would be useful in the L3 data. So if you're in a LDS DUR, then you can import this template, and then you'll have the manifest table, and then this logic that you can use in here, like here it imports these columns when it joins with this person level table. And so the fields here are data partner ID, CDM name, CDM version, whether the data partner ID shifts yes or no, and then the max num shift days. And then I left the logic there because I feel like it's better to leave it up to the research team to determine what the threshold is on how to filter out the ones that are shifting, let's say 30 days or 60 days. But once you do this, you'll have that data appended onto your data set. And so like each row will be one person corresponding to one data partner ID that will give you this value, max num shift days. And then based off of the values that you see, let's say 30, 60, 90, you can then filter those out. And then one other thing that I just remembered is that we also have a node here that, again, this is for L3 data, but for both the L2 and L3, you can use I think it's the postal code data set. And then if you have L3, then you can connect it to a location table that will give you the postal code, and you can use this to make visualizations for like a heat map for patient location. And then I'm seeing some other questions. So does that ensure that if some of the data is shifted, that the patient will be filtered out? Yeah, so this is kind of tricky because I know that the value that you see here, the max num shift days, is a random value. So, well, the value itself is not random, but it's the max number. So if this number says 100, then the number of days it could be shifting could be anywhere between 0 and 100. And so you can't really tell what each row is being shifted by. So it's hard to determine how to filter that out. But let's say if your threshold is 100, then you could see how many values have 100 shift days as their max num shift days and filter it that way. But yeah, you might lose some data that doesn't actually shift the entire 100 days. And then I see another question that says, I am curious about how you decided on information on inpatient status, such as admission date, discharge date, medication administered. Did you use the macro visit table? So we used the visit occurrence table, but we can, we're always incorporating suggestions, and we'd be happy to add this into the template too. We can add the macro visit table into here, but we use these 4 values for visit type, which the concept name, when you look up these, are what you see here. So for 262, we saw ER and inpatient. 8717, we saw inpatient hospital concept ID. So we stuck to the ones that like said inpatient in the name, but I know that some people are working on more string matching ways to get a more inclusive definition of an inpatient admission. And the logic that you can use to determine inpatient admissions, you could also use date differences of whether it's close to the index event that you're interested in. So for example, if you're interested in stroke, that you can form some logic of how much time passed between their visit start date and their stroke date, and you know, develop your own threshold for that. So does anyone else have any questions?
Well, this is fantastic. Now, thanks, Arti. So what fraction of domain teams do you think you've been working with? How, and maybe you could talk a little bit about what sort of orientation and training you offer.
Yeah, so this is a really good question for one of our other leaders, Johanna, but we've had, I would say, 1 to 2 representatives from each of the domain teams that have a logic liaison. And the full, I think our full membership might be, I'm guessing here, so don't quote me on this, but I want to say it's around 10 to 20 people. And so we meet every other week, and it's open to whoever wants to suggest any, you know, tips or best practices. And we have our own shared Google space, and we have this document where we've compiled all of our discussions and lessons that we've learned while working in N3C. And I'm happy to share that too in Slack or through developing a report. But most of the information that we've discussed is throughout this document. And we've had a couple of other presentations from other groups come in too and talk about other various topics.
Mm-hmm. No, this is great. This is really valuable. Definitely, I'm sure you've shared it through Slack in various ways already, but I'm sure that would be useful.
So Joel, I can answer that question a little if you like. So this is Johanna Lumba, and I worked with Arti on this, and I co-lead the Logic Liaison team and work at UVA and iThrive. So we definitely aim to make this a funded service that we can actually provide requested support for anyone working with this data. And that was proposed in part of the PASC proposal that went in for N3C for the 1Z proposal. So we're waiting to hear on that. At least I'm waiting to hear on that. And it's also been part of some other proposals. At this time, it's just volunteer, right? So we took the work that we've done and launched this discussion group, and it's really people who are working in volunteer capacities across the domain teams. So we'd love to see it be funded, but in the meantime, we're trying to just do what we can with the kind of knowledge of the community that people are actively coding. And we do keep it a closed group at this time just to really be able to focus the discussion on people who have a lot of experience in the code. That helps us have really productive meetings when we meet instead of having the whole range of, kind of questions and things.
Right. I'm sure.
Yeah, so we're trying to take that fruit out and put it into this kind of tool that people can use and access for any kind of research question. Is kind of agnostic to the work that you're doing. Mm-hmm. Hopefully it accelerates your work no matter what your question.
Yeah, no, that's fantastic. It really would save a lot of groups, a lot of redundant effort.
Yeah, and if anyone has any suggestions later, we're happy to talk about that and incorporate that into here too.
Great. All right, well, thanks. I think this is real useful. And any other, I see there's a new message. Thank you for participating. All right. Okay, well, thanks. And we'll give folks 3 minutes back if there's no other questions. And thanks to both presenters. I think this is a great session. So have a good week. We'll talk to you on other things. Bye-bye.
Thanks. Bye.